let's understand folding symmetry method. This folding symmetry method is once again a method based on symmetry. It is once again based on the points which are at the same potential. But there is a slight difference what we did in mirror image method and now what we are going to do in folding symmetry method. In mirror image method, if you remember, that is, if these A and B, they are the 2 points and this is kind of axis, so we had put a plane mirror perpendicular to this axis somewhere over here, and then we had arranged the resistance something like this so that one half is image of the other, and then we collapsed it. So our plane or mirror, it was perpendicular to this axis. But in folding symmetry method, we have a plane along the point A and B. In folding symmetry method, we look for an axis like this, which is along AB. This axis is along the line joining A and B, across which we have to find the equivalent resistance, and this they are identical. Then what we do, why it is called a folding symmetry method is, see now we can just fold it and put it over here. That is, if we say this is point X and this is point Y, if this is X and this is Y, X and Y, they can be folded, they can be connected together. If we say this is L and this is M, they can be connected together. That is, so we can flip and we can connect the points, this over here and this over here. That's why this is called folding symmetry method. As in the mirror image method, we have collapsed all the points. Now in this method, that is folding symmetry method, we are not going to collapse all the points. Once again, this method is based on joining the points which are on the same potential. Like over here, if you see, that is, if the current I is coming over here, it says that is both the paths are identical. There is no specific reason. That is, in one of the arms there should flow more current and in the other arm there should be a less flow of current. When the current flow in both the arms they are equal, it means the potential drop across this and potential drop across this, it has to be same. If it has to be same, it means the potential of X and Y, that is going to be same. Similarly, the potential of L and M, that is going to be same. But that doesn't mean that is potential of this is also same. This is one point. This and this may be at same potential, but this wire is also connected over here. So we cannot directly remove this wire. So once we fold it, so now we are going to fold it. This is the upper half which I have drawn, R, 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 R. So this is all the resistances, they have been drawn over here, including this axis also, it has been drawn. Now when we are going to flip it, so now when we are going to fold it, this is going to be over here, this and this, they are going to get connected. This is going to be over here, this is going to be connected like this. Let's remove R so that we concentrate more on the resistances and the network. Its work is done. This gets connected over here. This gets connected over here. That's all. This is represented over here. So now what we have, this and this, they are parallel. From here, this and this resistance they are parallel, 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 and one we had missed it over here, that also comes, this and this resistance they are parallel. If between A and X, that is when we say X over here, the Y has also come over here, so Y junction is also here. When we say L is here, so M has also come over here. So this is the kind of network we are going to have. So now this and this is parallel, R and R they are parallel, so they make a resistance of R by 2. If you look over here, once again, this is R by 2. Let's say this is X and Y is here, L and M they are here, R by 2, this is R by 2, this is R, this is R by 2, this is R by 2, and over here we have B. Now we have to find the equivalent resistance between this A and B. It is much easier. This R by 2, R and R by 2, they are in series. So that makes R by 2 is here, A is here, So this R by 2 is here. This is R by 2, R plus R by 2 plus R by 2. R by 2 plus R by 2 is R plus R, 2R. So this is 2R. This is R by 2 and this is B. Now this and this, they are in parallel. This and this, they are in series, and you can find the equivalent resistance